So before I lower the screens down, we'll get back to the presentation. So this is we're going to refer back to what you guys have on the board, kind of throughout the process. I shared this with some of you, but the main reason I wanted you to go through this exercise is one of the things I want to talk about today is some of the negatives around microservices, some of the things that fall apart. Some of the things that you got to plan for if you are going to go the microservices route. It's just like anything else. Everything you do out here, especially in the software world, has its pros and cons. And so I want to hit on some of those cons because, again, today is all about practical microservices, real-world microservices. And I'm not going to talk about the idealistic textbook microservices. I'm just going to talk about what I've seen, which also lends itself to be my opinion. So keep that in mind, that what you're hearing today is just what I've seen out in the world. It's my opinion of, I guess, what I would consider a good way to go about it and a good approach. And a lot of it comes from a lot of failures. And some things that we ran into with some of the microservices architecture that I stood up personally, both at some of my clients' places and at the startup companies I'm in. So the reason why I had you do this is because, not that we're going to pick on anybody, but we're going to talk about edge cases, things that you're going to run into with this type of design that if you don't plan ahead, get you in real trouble, or in my case, get you fired. So I don't like that. I'm sure you guys probably don't like that, but it happens. But just to be able to prep you for the future and prep you for your design. So with that said, let me just get these down. All right. So we had some great conversations while you guys were working on the board. A lot around what makes up a microservice. And again, just like I just mentioned, what you're going to hear today is my opinion of what makes up a microservice. Doesn't say that it's going to work for where you're working at, or for your company, or for your application, or what the textbook says. It's what I see as a good division line for microservices, and where to divide everything up. So I'm going to show you a couple of diagrams that I stole off the web. There's a great quote from a West Wing episode where I think Rob Lowe says, good writers write their own stuff, great writers steal from the good writers. So I stole these diagrams from the web. But I think they're really good concepts on what makes up a microservices. And I got a couple slides before this. I apologize. I'm a little off script. We're just going to touch on some basics really quick. Stuff that I want to touch on because I didn't know when I set up my first microservices architecture. I kind of went off the textbook and didn't understand some of the concepts. And we quickly shifted over to what you're kind of going to see today. First is the concept of an atomic microservice. So this is a single microservice that I'll just anchor it on an example, an organization microservice. It's a microservice that serves up organizational information or your company's information, not a customer's information. Or a microservice around, say, orders. You have a company a shipping company, and orders come in for shipping out product. A single atomic microservice is around that order. That's what I consider an atomic microservice. Composite microservice. This is one that I struggled with a lot because of that whole idealistic programming that we talked about before. The whole idea that I felt with microservices architecture is to decouple it from everything else. So you decouple it from systems, right? That's the whole point. Go away from monolithic, decouple everything into their own physical isolation services all the way down to the database. The database itself is in isolation. If you haven't read up on microservices, the hardest thing that I've seen in the real world is going from one database to 1,000, which is what the textbook says you should do with a microservice, is your database itself should be for that particular microservice. And that's a really, really hard thing to do, especially if you're rewriting a system. But it's also hard for everybody around you that has come up through the ranks of gigantic SQL Server or Oracle systems where you got foreign key relationships and triggers and stored procedures that you can't do across databases. So that's one thing we're going to kind of talk about. It's one of the downfalls of the microservices. I wouldn't say downfall, but it's something you got to plan for. And I didn't plan for in my first set, and it kind of shot us in the foot. So the idea of a composite microservice is a microservice that talks to other microservices. Again, and not by textbook, but by practical applications of it. I struggled with this because I didn't want a microservice to be dependent on another one. So this is where your DevOps and your CI/CD really comes into play. What looks like a composite microservice, we had a microservice that served up orders, line items, quantities, things like that, all inside a single microservice. That was its domain. We had another one that, a completely separate microservice that served up the customer's information. And we had a separate one that served up the address or shipping addresses. So addresses by themselves were a microservice. And our UI had to hit all three atomic services and then marry it together. Now, if you think about that, it doesn't seem like that's a big deal. But now we're talking about an SPA app that's written in JavaScript that's got to take three completely sets of data and within JavaScript, inside the browser, try to marry up these data that should have been married up originally. A composite microservice brings that together. So you have a composite microservice that you can use on a use case basis, for instance. You can stand up a microservice that is for, give me the shipping information for all orders for this customer. Okay, you pass in the customer ID and a date range, and this composite microservice hits your three atomic microservices behind the scenes and then marries the data up together before it presents it back out. Now, I struggle with this. I don't know if you guys have or those that have been in this realm. It's a tough concept because anytime you make a change to those three atomic services, it could affect your composite service. And so one of the things I'm going to keep hammering on is your CI/CD and your DevOps process. Because once you check that code into that atomic service, and of course you obviously don't want to do breaking changes to the service or to the endpoints, it should also kick off a build for your composite service, and both of those should get promoted up together. So that kind of goes into your DevOps process. So API Gateway, I was talking to a few of you at break. Another one that we struggled with, another one I failed to stand up at a particular company, a lot due to financial reasons, but also due to lack of experience. Your API gateway is a crucial part to your microservices. It's where all your traffic flows. It's used for a lot of different reasons. One that we struggled with is security around your microservices. I'm a traditional .NET guy, so we did authorization right at the endpoints. But for those of you that have over 1,000 microservices out there, and I'm guessing you have multiple endpoints per microservice, right? You're talking 10,000 endpoints that all got to have an authorization tag on top of them. Yeah, you can imagine the complexity. I didn't realize when I was standing these up that you can take an API gateway and you can do your security right there. Boom, done. And all your microservices, as long as they flow through the gateway and behind the firewall, don't have to be secured back that. It's secured in a different manner. We use a client secret, client ID between the API and the gateways, but that's a lot easier than trying to do permissions or role-based permissions on those endpoints. So putting up an API gateway, amongst a lot of other reasons why we do API gateways, but you can terminate your security mechanism right there at the gateway, as well as trafficking and whatnot. The other important aspect of an API gateway that, again, I didn't have any experience in, is there's this concept that you can actually stand up routing based on your consumers. And I was thinking about this. I'm like, well, why would you do that? You want to have a microservice that serves up orders, and you want to have a microservice that serves up shipping addresses and whatnot. Why would you build something specific for a consumer? Because if you've got a team that's building a UI and they only need 25% of the microservices you got out there, and then on top of that, they've got to marry everything together because you don't have your composites set up, or even if they use the composites, you can actually do all your routing within the API gateway specifically for a particular application. For instance, in the case that we just did up here, your customer portal can go through one gateway, while your client services application can go through another gateway. And there's a lot more to it that I probably won't get into today, but I encourage you to go look at it, look at how it fits into the microservices realm. And with the cloud platforms today, their API gateways are out of the box and very easy to set up. So it's almost at this point a no-brainer if you're in the cloud. And I like to hit on the data warehouse, and you're probably asking, what the heck? That has nothing to do with microservices. But when you have 1,000 databases that you can't do any kind of reporting around, I actually, when I go in now to my clients and I pitch microservices architecture, I immediately pitch a data warehouse. Because at some point, they're going to want to get that data all into one spot where they can hook up Power BI or some reporting tool to report on that data, or some sort of client analytics portion so that they can see that data. And I use the term data warehouse. Really, it could be anything. It could be just a central database location where you massage the data and it comes in, and maybe you do some sort of summaries in it or whatnot. I'm not a data warehouse guy. I'm not going to pretend that I am. But I do pitch it as part of the architecture right away. That is a key part in my opinion. And of course, it depends on your business needs. You might find out that you don't need it, but if at some point you're going to need to take 1, 2, 10 of those databases and merge them together for some back office processing, or to feed the data back out through another atomic service or whatnot. So keep that in mind when you're doing your architecture, to look at a data warehouse right off the bat. So I'm going to show a couple of diagrams, and we'll talk about some of the pitfalls, both with what's on the board and what I've got up here. But before I show them, this is around the concept of where the dividing lines are. I came up through the DDD ranks, or domain-driven design. So I built everything around the middle tier. So I built everything around objects. And I separated out all the business rules into those objects. You send in a shipping address, validation's done inside the middle tier of, do you have an appropriate street? Do you have a zip code? Is there a customer ID attached to that shipping address, et cetera, et cetera. I brought that up purposely in the beginning because I feel to do proper microservices design, you've got to separate it out by domain. This is my opinion of how microservices should be divided up. I use some very key concepts, simple concepts, to break my services up. If you follow some simple rules, I think you can set up a pretty easy microservices structure. I use the rule no more than 10 tables in a database. And again, if you look at the textbook, a true microservice, it could be not even a table, not even a database. It might just be a simple single endpoint, in the case of REST, with 5 actions on it. That's it, just one endpoint. In the practical world, I don't feel that that's overkill. So I take the approach from my old days of the domain itself. So I look at a customer. All right, you got it. You're building a system. You got customers out there. I'm going to stand up a microservice that's called customer, and it could have 10 tables in it. I'm trying to think of a good example right now. I always use addresses because that seems to be the simplest one. Or orders. Orders has line items, quantities, but doesn't have products in it. The raw product that you're shipping is in a separate microservice because that's raw product. That's what you're producing. Orders and line items are in a separate microservice in a separate domain. So that's kind of the dividing lines. And every place is different. You have to kind of figure out where your domains separate out. So this is kind of just, in my opinion, the simplest idea of a microservices design. You can see up here, these are composite microservices or a combination thereof. These are your atomic services. They go strictly right down to your SQL Server database. And then you have your API gateway in front of it. You don't care about your consumers. And if you remember, and I'm going to bring up this just side note that I see a lot of, is it's difficult when you get on a team to not think about the consumers or think about a single consumer in their use case. When you're developing microservices, you want to think about the fact that you could have 1,000 different consumers with 1,000 different platforms hitting that one microservice through the gateway. I'll give you an example. We were building a microservice to support a specific product line that was already in the market, and we're going to switch it over. And my whole team kept thinking, well, we're just going to do it, for this product line. And you got to step back and you got to think, and this kind of goes against what I was saying earlier, but if we design it this way and we put all this extra stuff into it, eventually somebody will use it. That's not what I mean. What I mean is designing it without the consumers in mind. Designing up, what are you serving up? I'm serving up orders. Okay, order data. I'm serving up line items for that order. Okay. I don't care who consumes it or how they consume it or how they look at it. And you shouldn't change the data packet based on the consumers. Let them worry about that. But that's how we divide up the microservices. So try to abstract yourself out away from the consumers and what they need and prepare them just to be basically completely encapsulated and isolated out. This is another one I thought was pretty good because it shows the storefront web app as a composite microservice. If you notice, the storefront web app, that's a web app. I was going to use this. Actually, I want to use this as an example as a composite. A lot of composites don't talk directly to a database. They're strictly, in my opinion, a lot of them are there to massage data and bring it together from your atomic web services. And you can think about this at the data level if you want. If that's easier to envision, you can do that. That's how I typically do it. So I look at it, okay, what data am I serving up, and how do I want to bring it together? But that's how the composite ones work, is typically they don't hit a database. They basically bring that data together from other microservices. So this one might be a little hard to read, but this is the one I wanted to hit on the composites. So these are your core atomic services. I can't remember who I stole this from, but I thought it was a good separation between the atomics and the composite microservices. And this would typically be your API gateway. I think in here they call it API services, but it's a lot of times that's built into your API gateway. So I just wanted to throw these up there to kind of give you an example of what that looks like and kind of touch on that. Before I move on to, I want to talk a little bit about benefits and pros and cons. We're going to get into a lot of that. But before I do that, anybody have any questions around those kind of basic concepts?
The only question I have is, how do you manage the relationship between the domains?
For example, define relationship.
Yeah, customer and order, or product and order. Mm-hmm. There is a relationship between them. Either it is one-to-many or many-to-many type of relationship.
Right.
So if it is in a different API and in a different database, how can you do that?
So you're hitting on something that some of us already talked about. How many of you have done database development? Raise your hand. Okay, I figured it pretty much everybody, right? How How many of you, out of those database developments, have you put in foreign keys, triggers, stored procedures? Okay. The hardest thing that I find in the real world, moving to microservices and breaking apart a monolithic database, is a concept that I refer to as orphan objects and rows in the database. If you've been around the block and you've seen this, it's back in the day that was an absolute no-no. You don't have orphan objects in the database. You talk to a database guy and they'll throw you out of the room. Microservices really embraces orphan objects in the sense that, to your example, if you have a microservice that serves up orders and line items, somewhere on that microservice is going to be a customer ID, a GUID or an integer of some kind, on the orders microservices. The customer, the source of truth is your customer API or your customer microservice. That's your source of truth. But to refer back to the orders, you got to pass in that customer ID in order to filter the information down. Now, you blow away that customer out of the database, and now you got all these orders sitting out there that you could access that are there. Those are orphan objects. There's no integrity around it at all, like there used to be back in the day. In a monolithic database, you destroy the customer, the 100 tables underneath it all get cleaned out as well. You can't do that in a true microservices architecture anymore, at least not the way we think of it down at the database level. And I walk in and I preach and talk about that this is okay. And the reason it's okay there's a lot of reasons. The reason it's okay, unless it's a true transactional database where you're throwing up log messages, or even in that case, it's probably not a big deal. But in a gigantic monolithic database, you're just not going to be jamming in enough information where orphan objects is a big deal. Because nobody's going to access the order record for a deleted customer typically. If you delete the customer, the first thing that any consumer is going to do is check to see if that customer exists. Or you run it through an API gateway and you do the check at the gateway level right there. But at the database level, it's okay. All those orders stay there historically, and the customer is deleted, but the orders are there. That's fine. Typically, we stand up a back office process that goes through all the databases and eventually cleans that out. But also, if you haven't done this already, and I embrace this with the design, is we do a concept of deferred deletions. Have anybody heard of that term? Deferred deletions? Anybody else? No? Deferred deletions is a concept that came out where basically we didn't want to blow away any data. We didn't want to allow anybody to delete data out of the database. So you put a flag on every record called is deleted, or is gone, or don't blow me away. But you put a flag on every row, a column in every table that is marked as deleted, and then of course you use your date modified and date creation columns. And when you delete a customer record, you just mark it deleted. So you still technically have your integrity behind the scenes. Even though that customer is deleted, it's truly not physically deleted out of the database. And typically we would write a back office process. I never got to this stage as a consultant, but usually you'd write a back office process that goes through all the tables and looks at the last time that record was changed. If it's a year old and it's marked deleted, blow that record away physically. That really truly never happens. We never get to that stage. If you got a DBA in this room, they'd be on fire right now with me, right, talking like this. But the real world facts is you never get there. By the time you have to clean out the data, it's 10 years down the road, and you've already moved on to a whole nother architecture. And they're probably already going to move to a completely another database system or NoSQL or back to flat files. JSON and text files, because I think that's next. But but you're not going to have to worry about it. So those are the key concepts I do with microservices. If I do get the option to stand up a database system with the microservices, I do defer deletions, and I don't worry about enforcing any kind of integrity on the data itself. So far, this is really holding up true because I think, in my opinion, the world is moving so fast that the stuff you're writing today, in my opinion, is going to be sunsetted in 3 years. How many disagree with that? Raise your hand. Yeah? You think it's going to be around longer than that?
I mean, the stuff that I'm working on was used for like 50 years. So I think 10 years maybe.
Okay. You work for Lockheed Martin?
No.
Okay. All right. You're right, and it depends on the industry, obviously. I'm probably making a little general terms, but
maybe just a little bit too tight. Maybe 5 or 8.
Well, I work for the business, with a lot of the business world, financial worlds, and of course the startup world. So the stuff changes so rapidly that in my world and the applications that I've worked on, I don't worry about longevity, quite frankly, just because in 3 years they're going to re-platform it to the next thing, and they're going to shift over from an old database to another one anyway. So
just kind of on this topic, do you think that there's any credence to the idea that, like, or maybe in your experience that you have a company, maybe they were on Visual Basic or something, and now they're like, oh, well, Go is like the way to build microservices, so we're going to move everything to Go. Like, have you had any experience with that, or
what?
You know?
Yeah.
Like,
well, somewhat. Yeah.
So how would you address that?
Yeah. Well, it's the old, you know, what technology do you use, and do you use a mix of it and whatnot. We run into that all the time. Do you use Node? You know, I mentioned JavaScript developers. How many of you are JavaScript developers? I want to be careful what I say. Just you? Come on. All right, there's a couple more in here. No, I'm not going to pick on you, but I've been in the back office world so much, and the back office processing world so much, that I'm very picky about how my APIs get stood up and get deployed. You have the argument all the time, well, especially if you're a JavaScript shop, if you're writing SAP apps or SPA apps, a lot of them are saying, well, if your whole company is JavaScript developers because you have a strong application platform, you'll see it all the time is, well, let's just stand up a Node server and slap a web API on, and away we go. Or what do we move to? What framework do we move to? I think Express is another really good JavaScript framework. We run into that all the time. In my world, most of my places are .NET shops and have come up through the .NET ranks. Now, I don't even like to use that Microsoft term anymore because everybody's writing either React or Angular for their front-end development. Anybody outside of those two technologies? What else is out there?
Vue and Ember.
What is it?
Vue and Ember.
Huh.
Angular's going down. No, I mean in terms of usage, it's.
Yeah, usage is going down. Yeah.
React is going down.
Knockout is
What?
knockout is more.
Okay.
Yeah, I think Azure is written in knockout.
Yep. Okay, what else? I want to hear other technology, other UI tech, because this is the world I don't typically
Yeah, it's
live
going
in.
to be all React and Vue.
React and Vue?
Yeah.
Okay. I'm not going to comment because I don't know if I'm in the right spot to comment, but to get back to your question, I mean it's just a technology conversation. So what do you move to? Like I said, I always stay behind the API layer, and the tooling around .NET and Java are really the two APIs that I've seen or I've worked on.
It's pretty standard with just like, what do you know, what are you good at, use that.
Yeah, basically. Yeah, and a lot of it comes down to resources in the shop that you're in. I've got a client right now in the GIS world that has moved everything to Angular and using AWS. So I wouldn't say they're not anti-Microsoft, but because of the resources that they have in their company, they all come up through the .NET ranks, and a lot of them are self-taught and Angular and JavaScript and whatnot. That one of the architects at the company just put a stake in the sand and said all our APIs are going to be .NET for no other reason than the fact that this is our talent that we have in the company, and it's our best route right now to get it to market. That's really what the argument is. That's what I'm seeing. So, good question. Really good question.
So I'm trying to understand the differentiation between the composite service layer and the core service layer. So, like, more so division responsibilities, is it the core services more so as actually retrieving the database information and massaging it, versus what does the composite service do?
Well, a composite service could be a lot of things. I want to go back, if I can, because I want to go back to kind of this. This is just a little bit easier to see. In the practical world, I use composites to bring data together, and in some cases present it out slightly different. I still follow the REST style. We're talking about REST standards. I call it REST standards, but it's not a standard, it's a style, where I'm very picky about how my URLs are laid out. And I'm trying to think of a good example that I have of a composite. A lot of times I'll put it right in the name. I'm trying to think, this is probably a bad example, but orders with line items. One thing I do with microservices is I have a flattened data representation. So when you hit the orders endpoint, you get just orders. You don't get line items with it.
So services, so the atomic level will be just the orders at that point.
Just bring the orders out, yep.
And then the composite then.
Correct. Well, composite could be a combination of both. It also could be a filter mechanism. It could be where, for instance, you can pass in parameters for, say, give me the last whatever day worth of orders, or your base series. That's a bad example. I'm trying to really think of a good example to answer your question. But I use the composites to bring like orders and line items together, and that's where I'd put the endpoint in. I'm trying to think what we did down at GC. I'll come back to it. Let me think about a good example. But that's where I would bring data together, is in the composite. So, and that's a tough thing. That was a tough thing for me because I think it breaks REST, in my opinion. The style, you got an order, you got line items or a get on line items, and you pass in the order ID. But in the real world, even REST, even the REST style that Roy kind of defined, falls apart in the real world, because he says that everything's built around a resource. You're going to get a resource. I'm going to get orders or a collection of orders. You're not supposed to have anything else with it. If you want line items, you go back in and you get line items. In the real world, that doesn't fit, because now you're asking the consumer to make 1,000 round trips, and this literally happened to me 6 months ago because I didn't lay out the composite correctly, where once the product team went to implement it, I think they were doing 1,000 calls just to bring back the data they need to present it. And so one of the lead developers came to me and said, this isn't going to work. He says, you got to change it, because what you'll see out there when you guys get into these microservices development is once you put it out there, everybody thinks it's set in stone. And they won't come back to you. They'll be just like, oh, well, this is what they gave me. You're the microservices guy, and I'm just going to do what you told me to do, and I'm going to implement it. And you never hear from them. And so then I start walking around, I start talking to the other product teams, and they're like, oh, there's that guy. There's the microservices guy. So, it's good to get out and talk to your consumers so that you can find out where your loopholes are in your microservices, and that's a classic case where the idealistic style of both microservices and the REST style doesn't lend itself in a lot of areas to how the practical world works. So.
Where does the business logic layer fit into this? So if you've got like line items and different things and you got to multiply it, most places have rules for tax stuff. If you just have a traditional thing where each thing would be its own microservice, where is that implemented? Does it have to be in the client, or is that where you would put a composite microservice in place?
My famous line, it depends.
Yeah.
Is Mott's, that was Mott's line. It
Yeah, it's
depends.
ingrained in all of us.
I always put, first of all, I always put business logic behind the API layer. When I hear a consumer out there is doing logic, unless it's specific to their product line, we'll put PBIs in the backlog and bring that logic behind the API layer. Because that means, in my opinion, if the UI is doing business logic, then I screwed up and I missed something. You really do have to take it on a case-by-case basis. Tax is a great question because I don't know if a lot of you use a third-party tax tool. I had a project where we actually had to hit a third-party tax tool to calculate tax based on zip codes. And that was a challenge architecturally because where do you hit this third-party service? In that case, we stood up a composite microservice and we did the tax calculation after we fetched the line items. So we'd fetch the line items, call the tax service, they would bring back, we marry the data together and send it out. I did not do it down in the atomic microservice where orders and line items reside. Really, in my opinion, and this is tough to do, but the atomic services are really just straight to the database and back. Bring it back out, send it back out, map it to your business objects and send it back out. I do a lot of the logic, and there's logic there, of course, but then I do a lot of the logic in that case in the composite layer. So.
Yeah, I was going to mention, like I work at Target on the point of sale system,
Yeah.
and we have a monolith. I mean, it's been 20 years. People have coded for millions of lines of code. So now we're trying to break it up, but there's humongous amount of business logic that has to be now separated out into the microservices. One of the things that we have done is, for example, when you scan an item, right at the scanner, it goes to a core item service, microservice, that then calls all your promotions, discounts, tax, restrictions. So that is behaving as the composite microservice.
Exactly.
Yep.
Exactly. I'd almost characterize a composite as if it doesn't go straight to your data layer and back out in isolation, and it's hitting 2 or 3 different systems, it's a composite. That's really, in my mind, a definition difference between a composite and an atomic. Like an aggregation layer, absolutely. And we use composites for aggregates as well. We'll change the whole object, the model itself, when it comes out of composite. So what you get, and we've used composites to, for instance, in the case of an order. So an atomic microservice that returns out an order, it could be all the data properties that make up an order, every piece of it. But we'll drop in a composite in front of it to shrink down that model, and we'll call it something else. And I'm kind of paraphrasing a little bit about how it went down because that wasn't orders. But in a lot of cases, like in an order table, like there could be 50 properties on that object or coming out on that data packet. In a composite, we'll strip it down to 5 properties because that's all we want to return out. Call it streamline orders or web orders or non-shippable orders or wherever the case may be. We'll strip that down so that the data packet comes out a lot lighter.
And then so like when you do that or those type of architectures, or like is your composite or your aggregation layer generally your most complex?
Yes.
Or yeah, it's that like so. Then do you have your like lines to say this is where we stop adding to this? Composite layer, like I said earlier, you have rules that define your regular microservice, right? We say 10 tables max.
Right.
So then you have rules for that type.
Yep, and those are a lot more fuzzy. So the question is where is your dividing line between one composite to building out a second composite? And the rules are a lot more fuzzy, and I don't have specific rules because every place I walk into is so drastically different that I just kind of look at it and just find the logical break. It's a lot easier on the atomics. You know, when you actually look at domain-driven design enough, you start to feel out where those breaks are pretty quick in the domain. Orders and line items, customers, shipping, raw product, consumables, things like that. They all break up pretty straightforward, at least in my world. And then some of you out there are probably shaking your head because maybe it's not as clear in the world you live in. But you just got to sit down and feel that. But I use those guidelines, the 10 tables, usually I don't think I do more than 5 or 6 endpoints on an atomic microservice, even on a composite microservice, even though your composites could be hitting 5 atomic microservices, a composite still should only have 5, 6 endpoints. And the reason I set those rules in place, they're not textbook rules, they're just my rules. The reason I set those in place is for maintenance, because you don't want to get to this microscopic level because of the DevOps and everything around it's going to be just too painful. But you want to get to a point where you can touch that microservice without, with some level of confidence that you're not going to break everything else around it. Which is why I also be very careful with composites. Because if you have 10 composites that are all hitting the orders atomic microservice, you've coupled those 10 composites to that one. And now you've really truly got a maintenance problem. Or depending on your DevOps process, it could be easy, but most likely not. So you got to be careful of where those dividing lines are. So there isn't a really good, I don't have a good answer for you. But I would look at how your composites, if you're standing up 10 composites that are all encompassing an order, atomic, or a set of orders, or maybe a set of orders and line items, I think something's wrong. We call it, anybody use the term smell test? Yeah? All right, good. Yeah, smell test. It's just it's a gut feeling. If you got 10 composites that somebody stood up or your teammate stood up, and they're all hitting the orders atomic microservice, red flags go up all over the place. Something's wrong. Maybe it's too small. Maybe we're not thinking about it logically. So that's how I do it. I just do a smell test on it. So good question. Good question. Anybody else?
Just a comment about this is you made a statement about when you're building your microservice APIs, you don't think about how the clients are calling them. And the one place that really breaks down, this diagram seems to assume that everything is HTTP with JSON bodies, right? Well, that requires TLS for security, for transport, and when you get into the IoT world, that breaks down in a hurry because getting certificates, most of the tools for embedded development there don't have good support for certificates or a lot of memory headroom. So you end up having to have something else.
Right. Now, what you're talking about is a transport mechanism. When I was talking about don't worry about the consumers, I meant on a logical basis. So I don't worry about a consumer saying, I don't care about raw products. I don't care about floor quantities or whether the printing machine on the manufacturing floor is operating. I don't care about any of that. All I care about is the customer and the orders that they are being shipped. That's would be what a consumer's use case would be. That would be your customer portal, right? In most cases, let's just say, logically. I don't build a microservice around what they want. I build a customer microservice, and I build an order microservice, and I build a product microservice, and a security microservice, and a machine microservice that tells machine status. The consumers get the opportunity to mix and match what they need for their product. That's what I refer to as not worrying about the client. Yeah, transport mechanisms, absolutely. You got to worry about that, of course. And in my world, quite frankly, it's all HTTP and HTTPS and TCP. I don't get into the world of IoT and these other transport mechanisms. I was asked at one point to make sure that all microservices both brought out JSON and XML, and I just about fell off my chair. Does anybody use XML anymore? When you have to. Yeah, right? But yeah, to be backwards compatible, they wanted an XML packet brought out. So I had to worry about, the transport mechanism and what was presented. Yeah. Well, yeah. Not in the real world, but yeah. Yeah, I wish it worked that way. So, good question, though. Anybody else before I move on? Yeah.
So in my experience, I typically don't differentiate between this composite microservice and the atomic microservice. The idea is what I try to represent is the microservice reflects some subdomain, specific domain. And if it needs to span across different domain concepts, so for example, I have a product catalog domain, but I have a pricing domain that's separate, each represented by separate microservices. Once we start talking about, I think what the composite is trying to address is talking to multiple ones.
Right.
Once you start getting into transactional natures, like I need to ensure that this happens and then this happens there. This is where I kind of see like the separating those might fall apart. So for example, maybe the product catalog service needs to update the price or get the price from the pricing domain. So it kind of itself has the composite nature where it has to go to another service. So now the question becomes, well, how do you ensure that distributed transaction works correctly? And that's where things such as domain events saying, I want to start creating an order has happened, and you pair that with distributed transactional patterns such as 2PC or Saga, and then combine that with event sourcing. And then that's how you eventually get the distributed transactions to go across. And then you remove having to create like separate related composite microservices, and you keep your core one, but it still is able to do these distributed conversations.
Right, and I mean, everything you hit is right on. Actually, I like that you hit on the fact of transactional records, right? Cross microservices, it's one of the downsides. How do you ensure that you hit a composite that's hitting 5 atomics that are going to the database? How do you ensure that all 5 of those operated? Because you can't sit there and hold up the client. They're not, I mean, they're certainly not. They're going to do a fire and forget or asynchronous processing and wait for a callback. But how do you ensure that everything has happened? And that's where you start getting into event-based processing and whatnot on the composites. It's a real true problem and a real downfall of microservices. So just like everything else out in the world, it's like you weigh out your pros and cons. Do I build up one single web service or one single web API that serves up everything so that I can do those transactions? And then you run into other problems, right? So you cut your losses. It's the same with the Orphan Objects and whatnot. So there's a lot of downsides to the microservices approach. And like I said, and I'll put the disclaimer out there, it's not for everybody. It's not for every architecture. So, but yeah, it's a real life problem right now. So how we've been handling it, transactions, at least the few that we built in, is we literally ask the consumers to come back in and check status. So because a lot of the stuff takes minutes to process in some cases. Or we'll even fire off records into the database, and there will be a back office process that's chewing on it and sending it over to the data warehouse for analytics. And then the data warehouse kicks it back and says, hey, you've got a problem with this order. It's missing, tax or whatever. So we actually have to feed that all the way back to the consumer, and the consumer has to come back in and check the status of their order. There's no other good way for her to do it. At least I haven't found a good way. I'd be up to hear if anybody's solved this problem. It's because it's a problem. So good. We really kind of already hit on a lot of the benefits. I'm just going to kind of throw up a lot of, I guess, just really what I'm seeing. I see a lot of multiple teams that work on these. I'm assuming those of you that are out there working on microservices, it's not just one team. There are multiple teams. I'm saying, raise your hand if you got multiple teams hitting a microservice. Okay. Yeah, it's a real problem when it was all in one and you had multiple teams hitting and you didn't have a single person that understood that particular domain and could control the design. I'm even finding lately, for some reason, I don't know if it's financials or what's going on, but the market isn't lending itself to having proper team composition, architects, leads, developers, testers. One place I'm at right now, the architects are writing code right now, which is great, but because they're writing code, they can't oversee other people's designs. And this is a real problem, and they recognize it, but they're caught in a bad spot because the company can't afford to bring on more resources to allow the architects to do what they truly need to do, which is oversee all the teams and all the microservices that are out there. So with microservices, at least we have, this physical separation, and that's the key. Is traditionally back in the day, you touch something, you have no idea if you broke something else way over here. No 100% guarantee. With microservices, you have a physical isolation all the way down to the database layer, and you know that outside of your composites, you know that if I change the orders and line items, microservices, I'm not breaking customers, and I can roll it out. Which, just being mindful of time, lends itself into the startup world really, really well. So, and I'll talk about that at the end here. So, physical separation, I love this. I'm not going to break your stuff. You're not going to break mine. And the other part that I really like is if you have multiple consumers, different UIs, desktop application, and some SPA apps out in the cloud, they get to pick and choose what they want to hook up to, which is really nice. You don't have to worry about view models. You guys ever see a lot of view models, MVVM processes? Yeah, a lot of that you don't. There's still MVVM obviously on the client side, but you don't have to worry about that anymore. It's not the old MVC process that we used to go through. You throw up your domain, you throw up your objects, and you let the consumers worry about how they want to display that. So it's really nice. It takes a lot of load off, and that all shifts into ROI and financials. So, the one thing, and the reason why I had you do this exercise that we ran into on a project that, I don't know, it just kind of plagues me today, is we stood up a bunch of microservices with their own databases, and then all of a sudden we started getting in these requests from consumers. Well, I want to see this filter. I want to see data like this. I want to see data that was processed for the last 30 days. And they start throwing use cases at us. And what happened is because we didn't have a data warehouse in place and we didn't have an API in place, we had some composites, but most of them were atomic straight to the database because it was a fast project. We couldn't even field up their requests. We didn't know how to do it because the databases were physically separated. That was a real problem. And so immediately we stand up a data warehouse, and then the data warehouse, which typically doesn't feed back into your primary databases, we actually have the data warehouse feeding data back into the microservices database to update it for whatever processing. And in one case, we actually hooked the microservice up to the data warehouse directly because that was the only way we could solve that problem. Don't recommend it. There's better architectures out there, and any DBA would kill you right now if they heard that you're hooking up to the data warehouse. But that's how we solve that problem. So these are real-world issues that microservices have, is how do you present complex queries back out to the consumer? Large data graphs, this is more of a REST style than a microservice, but it's the same thing, is how do you do large data graphs? Even for pushing data into the system. I have a client, a manufacturing client, that their customers want to submit orders, and traditionally they would send in a huge XML packet that had everything from the customer's information to the shipping address to the products they wanted to modifications all in one single packet. So how do you go back to your customers and say, change your system because I need you to not make one call, but I need you to make 10? And it's a real problem. So that's something that you got to think about when you're laying out the microservices, is how, I'm kind of contradicting myself, is how are your consumers going to actually push data in, or how are they going to use it? You got to have an understanding of what they're going to run up against. You can throw it out there as single microservices and just say, well, if you want to push an order in, you push an order in, and you got to push line items, and you can do that, and we did, but it puts a lot of burden on them. So it's nice in some areas, but it does have problems when you start thinking about real-world applications. So,
have you seen the GraphQL resolve any of these complex query issues?
Yes. I have very little knowledge in GraphQL, and we toyed with the idea for solving this problem I just talked about. GraphQL is great. And I'm a big fan. I think it's going to be it's going to be really, really nice. As a matter of fact, I have a slide in here that talks about a little bit, hits on GraphQL and how it came out. Raise your hand if you know GraphQL. I just want to get a feeling from the room. Okay, so there's a few of you. I'm going to jump ahead. It's on a slide, but GraphQL came out from the Facebook guys in their R&D shop. It was a way to use a single, to take a single microservice and expand it out based on what the consumer wants. So the consumer actually, and correct me if I'm wrong because I'm little knowledge in this, but the consumer can dictate what the data graph looks like by tagging on some extra metadata on the request. We toyed with it because we have this problem in microservices, a general problem in microservices is how do I present data out in a single call versus 1,000 calls, and how do I marry the data up and whatnot, and do I build a composite, do I not, or do I use the API gateway? And what we found out is two things that stopped us from using GraphQL. One is the tooling, because we were using, there's a lot of tools with REST out there. You can use anything under the sun. You hit the URI, and you can see data right away. With Graph, you've got to have a program where you can feed in your parameters, because it's a large parameter graph, basically, in the request header, to say to the microservice what you want the data to look like. And we couldn't ask any of our consumers to do that, so we had to find a tool that they could download so that they could hit it and they could see the data. It was a real problem because there's just not enough tooling around it. But the other big problem was with GraphQL, everything goes through the gateway in a single endpoint. So you have a single point of failure. And when we saw that, we threw it out and just said, you know what, there's just too many negatives with GraphQL, or at least the current structure of it. So good question, though. But I encourage everybody, if you've done REST and you've done domain-driven design and business objects enough, look at GraphQL. It's a really cool technology. I'm still a fan of it. I'm still going to try to find a way to use it. I just haven't had any practical real-world applications yet to use it. So I want to touch a little bit on startups, and I know we're running out of time, and you guys have been here for a long time, so I appreciate your patience. You guys are really engaged. It's been great. So I like to throw this up because, where's the world going? And I'd like to throw this up because we talked about microservices have been around for a long time, and I don't think it's going anywhere. I think the concept itself is going to be around. So what you're going to start seeing, and what I'm seeing in the real world, I just want to touch on is, serverless technology, which I love it. It's just like the cloud. You don't need a data center anymore because you got the cloud. Well, it's a data center, isn't it? Same with the serverless. So we're going to go serverless. It's running on a machine over here in the cloud, which is not a data center. It's over there. But regardless, what I like about the serverless technology, the little bit that I'm touching on right now out in the field, is the idea that there's no infrastructure at all. You throw it up on a Lambda, and it only runs when it gets hit. It's something I encourage everybody to look at. Azure's got Azure Functions. We're hitting on serverless templates right now on how to quickly deploy the code out. It's basically going to take where we are today, and basically stream it right down. And I really truly feel like what we're going to see is we're just going to have all these endpoints and functions just floating all over the place, serving up what we need to serve up. So that's kind of where, but again, it still comes back to a proper microservices architecture or a microservices design, because that still feeds right into your Lambda functions and your serverless technology. So you're not going to lose anything where we're going today. Data analytics, I talked about this already. Data analytics is huge, and this is going to become even bigger because of microservices and the way microservices lend it out. So keep your eye on data analytics. I love it when they call it data analytics. It's really, it's just your boss coming to you and saying, I need to get to the data, and you've got it spread out over 1,000 databases. Now what do I do? That's what I'm seeing. But it's big talk right now, and then obviously that feeds into AI and machine learning and all those other cool technologies I haven't had a haven't had the pleasure to work on yet. So, I was going to hit on GraphQL, some other outliers, take a good look at that. Graph databases also is a big topic right now. I just want to touch on that a little bit, and how this fits into microservices. It's a real problematic because graph databases is a monolithic database, and it serves up data much differently than what a microservice lends itself to. So, but something to keep your eyes on. So let's just spend, I just want to spend a little bit of time talking about the startup community for a lot of reasons. One, I love the startup community. When I was sitting in your chairs, we had a great speaker who was doing a data startup. I really enjoyed his talk. I thought he hit on some really cool points. The one I remember is he said, working for a startup is amazing. It's the best work-life balance that you can have because you can work whenever you want, as long as you can fit 80 hours into a work week. I remember him saying that, and it's so true. It's really true. It's the startup world is fantastic. What I like about the startup world, I like to say total and complete freedom from a coding perspective. In the startup world, we write code, and we write a lot of it. And we throw it up as fast as humanly possible. So it's if you like writing code and you don't like business processes such as documentation or sprint planning or my favorite, sprint retros. Anybody who does sprint retros? Oh God, shoot me now. If you want to know how I feel, just come sit down next to me, and you want to ask me about retros. If you're getting bored with some of that stuff, and you just want to write code, the startup world is fantastic. All the startups I've worked for, and a lot of them I've headed up, you get a lot of freedom to explore different technologies, which is no documentation, no process. You really do get to try out new technologies. It's as long as you can get, if you find a new technology, I'll just use GraphQL for instance. You want to roll GraphQL into your web services layer because you think it's beneficial. As long as you can get it out the door by Friday, you can bring in that new technology all you want. You just got to have it out the door by Friday. That's usually the phrase in the startup world. It's great. It's like I said, usually the startup world's working on something new and fresh and with some sort of new technology that's out there. But of course, just like anything else, it has its pros and cons. How do Microsoft feed into it, or microservices feed into it? I rolled in. I'm on my third startup right now. And we did a microservices architecture. It was a SaaS application. And the great thing that I found with microservices was just the speed to market. And because we're a development team of 3, and we didn't have any testers, our testers was one of the founders, and they would test in production, because why not? That sounds like the right place to do it. So we would throw the code up there so fast. We focused, actually, in the startup world, we focused a lot on DevOps, just as much as we did on the microservices architecture. We made sure that when you checked the code in, it went right to pre-prod. I was going to say production, but we stopped that a couple weeks ago. We went right to pre-prod, and then we wait a little bit and then throw it into production. But I like the microservices approach because I could throw up, for instance, we threw up the customer microservices first, hasn't been touched. We throw up the orders microservices. Now that hasn't been touched. You can just throw up these microservices in isolation, and you don't have to worry about breaking anything else. I wanted to touch on that because it really lends itself to getting stuff to market really, really fast. So it really lends itself to the startup world. Yeah, the startup world, you don't have time to test. I know a comment was made back when I was sitting in your shoes of, and I can't remember to this day who said it. I think it was Mythical Man Month we were talking about. They said, in the startup world, your code is really throwaway code, and it should look as ugly as possible. And And it's really true. Until my third one, I didn't get that. And actually, my first startup failed because I wanted the code to look so nice, we never got it to market. So basically, you don't have time to write pretty code. You get it up there as fast as possible, which is great in microservices because there's not a lot of code in microservices. And once you set down the pattern, whatever pattern you decide on inside of your microservices, you can throw it up there and you can copy it, change the data, throw the next one up, and away you go. So you don't have time to test or any kind of formal testing. DevOps, I've mentioned this a couple times, I won't hit on it anymore. DevOps in general around microservices is an absolute must. So if this is the first time you're looking at microservices for your company or for a project you're working on, DevOps has to come right with it. And what I mean by DevOps is when you check that code in, you need a tool of some kind to push that code up to your production servers. And it has to be fully automated. That's the only way it works. If you get too many deployments going on at one time for anything to be manual. I use tools like Octopus Deploy. I heard another one. Where is he? What's the tool you use?
Jenkins.
Jenkins.
Yeah.
You use, you were telling me another one. Spinnaker. I haven't heard of that one yet. Yeah, I use Octopus Deploy. I use Microsoft's DevOps tool. And we spend just as much time in our DevOps tool and our deployments as much as we do in the code. And once you get it down and you get it locked down and you get it automated, you can start ripping out these microservices. So if you're in that stage, please take the time, find a good DevOps tool, push your boss or whoever to bring that tool in. We just had a client right now that had a heck of a time getting a DevOps tool in until we just basically said, we're just going to do it. And we bought the Octopus Deploy free version and rolled it. And now they're coming back and going to purchase the big one. Just do it. It'll save a lot of headaches. And no more deploying off of your desktops. I'm not sure who does that anymore. But anyways.
And so you use that like in conjunction with DevOps, like pipelines.
Yeah, like pipelines.
It's like on top of it that Octopus thing does.
Yeah. Yep. So Octopus is more of like it's got a lot of script. It's got scripting underneath. And they were married to Microsoft when they first got started, so they were doing a lot of PowerShell. And now because Microsoft basically brought in a brand new tool, Octopus has switched over to working with AWS more heavily, but it's all scripting. So they use, so for instance, my most recent project, we're using Octopus Deploy with AWS, and we're just writing a lot of scripts and using code pipelines to push those pieces up. So, raise your hand if you're familiar with DevOps. I should have asked that in the beginning. Or with the term at least. Okay. So DevOps is everything from the minute you check your code in until it gets into production. And it used to be this big thing back in the day. And there'd be teams of 10 people sitting in a corner just getting code out the door. And that's kind of all gone by the wayside. So get a nice tool in. It takes your code from point A to point B. It'll run your smoke tests. It'll run your unit tests. And it has notification in it and whatnot. But in the microservices specifically, especially who's got 1,000 microservices, you got to have a DevOps tool, absolutely. Just push it all up. Code checks in, push it up. Yeah, so basically, I'm trying to think what else I can tell you about the startup community. It just really, if it's something you're interested in, feel free to reach out to me. Does anybody have any questions? I kind of sped through it just because of time. Anybody else? Any questions about like the startup community or what it all means? I'll be honest with you. I think the biggest thing to hit on, and I'll probably get in trouble for saying this, but I'm going to say it anyways. If you're going to go into the startup world because you think you're going to get rich, don't do it. Okay? It's a lot of hours on a maybe. And I'll be completely transparent. I did it because a lot of it for financial reasons. But after my first two failed, I actually, when I look back, I enjoyed the process more than I enjoyed what was supposed to be the financial freedom coming out of it. It's the Wild West, and it's not. I think the last stat I heard is an 82% failure rate. Typically, in today's world, back in the 90s, they were giving out stock options. You hear about the first 100 people at Google. Everybody's heard about that. Yeah, they're all rich. Yeah, that's not the real world anymore. You'll get stock options for sure, unless you're one of the founding fathers. But outside of that, even those stock options you get, you're not going to be able to retire on, to be completely honest. It's just not the way the startup community is working anymore. But there's a lot of other benefits. It's just the sheer freedom, being able to have a say at a company. I know a lot of us work for some big name companies. Sometimes you feel like a number. In the startup world, the founders are asking you questions. Hey, how should we do this? And you tell them, well, I would do it this way. Okay, get it up by Friday. All right? I love that part of it. So on this last startup, that's the approach I took is, what can I get out of it, even if it fails? And so far we're still alive, but time will tell.
So the corollary I'm hearing from this is that you should never work for a company that's just exited the startup phase, because it's going to be like
yes. And I'm not looking at Michael over there, who is working at Sports Engine right now. If anybody knows, Sports Engine got bought out by NBC.
NBC Sports, yeah.
572.
572. What?
Million? Was that
purchase? I don't know what the number is.
Yeah, I mean, you could be at GitHub, and Microsoft bought GitHub for 7 point something billion. That's a beat.
Yeah. So what do you think about in the startup world where you're all just kind of racing towards the sellout versus if you're just trying to make a small business to sustain?
Yeah, we call them lifestyle businesses, and it's so gray. I didn't think it'd be as gray as it was when I started the startup community, because I thought it was a race to your exit. I want to exit in 3 years. I want to exit 10x, right? So if I put 50 grand into this company, I'm going to get 500,000 out within 36 months. Those are just metrics that we always hang our hat on. A lot of them turn into lifestyle companies. They just do. And the startup market's a lot harder today than it was back in the 90s. One of my co-founders on my current startup is in his 60s. He had 2 successful exits back in the 90s. And I'm sure if he was standing here next to me, he would second when I say it's nothing like it was back in the 90s. It just isn't. It's a lot tighter. The VCs are a lot tighter. They scrutinize everything versus back in the 90s when they were just throwing money at it. And then it didn't matter if you failed or not. So back to kind of answer your question is you got to be ready for that. But it's a different mentality. If you're racing to exit, your business approach is way different. Your coding approach is way different. For instance, if you're racing to an exit, I could care less if I put everything in a single function. If I have 10,000 lines of code inside this one function, I could care less, because I'm not going to be around in 3 years. If you're going to have a lifestyle company, you start looking at things like that. Even financials, can you stick 20 grand in or not? Because if it's a lifestyle company, you might not get that money. You're going to get that money back over 20 years, but you're not going to get it back in 3. So, yeah, but it's a lot grayer than I thought it would be when I started it. And I've seen a lot of startups change into lifestyle companies. So
do you consult and then you also have your startup?
I get that asked that a lot. And I was just talking to somebody in break about that. It's funny you say that. So I've kind of gone back and forth. Be honest with you, I've used my consulting services for my startups, which has been nice. But I've always had the intention that I would sunset my consulting services to do a startup. However, I haven't had a successful exit yet. So not only have I not had a successful exit, but my consulting company keeps taking off and won't shut down even if I try. So I have success over here, but not over here. And right now yeah, exactly, which is funny, because if you talk to any startup that's successful, and there's a great interview with the founder of Slack, that every one of them will tell you where they are today is nothing what they envisioned. And so if you plan to do a startup, the one thing I could leave you with is make sure you keep your mind open to what's out there, to what the market is dictating, and you're ready to pivot, and you pivot often. Get up there and get something to market as fast as possible. Don't worry about the code, and let the market dictate where you take it, and be ready to shift and turn. And by the time in 3 years when you're ready to exit, I guarantee your vision is nothing like what you originally had envisioned, what your product is. But if you pivot and you shift, you'll be okay. So, good question. Anybody else?
How you manage this product to market and quality and dependent? That means that most people, they feel, I don't know, I read a lot of blog. There is another person doing better than you or the other person, because the market is very competitive. Then you do the same type of idea or something, but if you don't publish it in the market without the quality, there is another person in the neighborhood who do better.
Yeah.
So how you?
Yeah, I've on this last startup, I've learned that very tough lesson is always first of all, there's 1,000 competitors all in your same market. There always will be. It's not like an idea that you can come up with somebody else hasn't thought of. That's a real life problem when you're out in the startup world. So you have to find the advantage over your competitors, obviously. What I've learned is that to make sure that your product's better, and I'll use Slack as an example, just to anchor this on a good example. You guys all use Slack? And most people use Slack, I would assume. It's just an IM tool. IM tools have been around forever. Microsoft even stood up Microsoft Teams in competition to Slack after Slack was launched. And I've been forced to use Teams at my client places. And what I find is everything else is clunkier. Slack is just smooth. The UI is smooth. You can do what you need it to do. And maybe it's just my world that I live in, but everything I can do is so much smoother. I use Slack as a great example of a huge competitive market that they've just dominated out of nowhere. And I contribute a lot of it to their UI, to what their UI can do. Now, what I'll say to that, because you are in a startup market and you have limited funds and limited time, is if you cracked open, I guarantee if you cracked open the hood on Slack, that code looks like crap. I guarantee it. It is probably the worst code you'll ever see. I can pretty much stand here and say that. Any good startup that's successful, the code underneath looks horrible. And you got to embrace that. You got to know that I got to have this all at the door, again, by Friday. But I got to do it in such a way that anything that's public facing has to work rock solid. Even if, honestly, in one of my startups, we were sitting nightly doing database transactions manually because we didn't have time to write the code to do it. So we would sit every night, move data from point A to point B so that the customers wouldn't notice that we were moving data from point A to point B. So that's the startup world. So make sure that your public-facing product is just rock solid and put all your time and energy into that. Don't worry about the back-end stuff. So, good question. Anybody else before we wrap this up? Last question. I'll stick around if you guys want to talk, and I'll throw this up here. You guys feel free to email me, send me a text if you have any questions. Otherwise, thank you very much for hanging out. That was a long session, so thank you very much.